Hello, welcome to Formulaic Utopia. My name is Sarah, and today we're going to be discussing how our perception of time changes as we age. So, for most of us, this is a pretty familiar concept. We're all kind of able to recognize that in our youth, days seem to just last forever, where now, as we're aging, every single day seems to be getting shorter than the last. And so, we want to investigate today, what's the math that's happening behind the scenes there? Why is this happening to us? And is there maybe anything we can do to help slow this process down? So, the first thing we want to evaluate is going to be a day represents what proportion of our lives, and how does this proportion change over the course of our lives? So, to do that, let's first look at the formula. So, we have a proportion of your life in a day is equal to 1 day divided by the number of days in your life. Okay, so what we're looking at is a day basically represents what overall proportion of your life. Okay, so let's evaluate this maybe from a couple different ages. So let's look first at the proportion of a 1-year-old's life in a day. So using that same formula, that would be equal to 1 day divided by the number of days in a 1-year-old's life, which is going to be equal to 1 divided by 1 times 365, right? We have a 1-year-old, which is where we get the 1 on the denominator, and we're going to multiply that by 365, the number of days in a year, okay, which is going to give us a decimal of about 0.00274. Okay, now that proportion by itself doesn't really mean much if we're not comparing it to another age. So maybe let's look at how this changes from a 1-year-old's to a 10-year-old's. So a 10-year-old, you have a proportion of a 10-year-old's life in a day is going to be equal to 1 day divided by now the number of days in a 10-year-old's life. And so that's going to be equal to 1 divided by 10 times 365. Now, if we wanted to get exactly precise with exactly how many days you've lived, let's say if you had lived 10 years and a month, you could do that, right? You could do 10 times 365 and add on your extra days that you needed to. But let's just keep it simple for now. So let's assume that each one of these people we're evaluating, it's their exact birthday, giving us a proportion of 0.00027. So let's look back at the proportion of a 1-year-old's life. So the proportion of a 1-year-old's life was 0.002, right? Where a 10-year-old's life is going to be 0.0002. So we've already gone an extra tenth of a decimal place, right, in the fraction of what a day represents in somebody's overall life just by adding 10 years in. Okay, now let's go to maybe another huge portion of somebody's life. Let's think of another great time, such as maybe when you were hitting the age of 21. At the age of 21, what proportion of your life is represented by a single day? Okay, so for here, we're going to have 1 day divided by the number of days in a 21-year-old's life, which is going to be 1 divided by 21 times 365, giving us a proportion of about 0.00013. Okay, so here we're still in the same tenth of a decimal place, but now the overall number has gone down by about half, more than half. Okay, that's a huge jump, right? That's a huge decrease in what the proportion, the fraction or percent of your day is represented by in the overall span of your life as you're aging. Okay, so let's continue on with this. Let's think about maybe another milestone when you are hitting the age of 40. What does that proportion of a day look like in a 40-year-old's life? So in a 40-year-old's life, we're going to have 1 divided by 40 times 365, giving us a proportion of 0.00007. So now we've gone down another tenth of a decimal place, right? And by adding on an extra 19 years to somebody's life, this proportion of what a single day in your life represents is getting smaller and smaller and smaller, and it's getting smaller at a rapid speed. So finally, let's look at what's the proportion of maybe a 65-year-old's life by the time you are retiring, right? What does that proportion look like to you? So here we have 1 divided by 65 times 365, which is going to be about equal to 0.00004. And so that proportion, that fraction, has gotten even smaller. And we expect this to happen because every single day that you live, right, this denominator is getting a little bit larger. And when this denominator gets a little bit larger, this overall fraction gets a little bit smaller, right? Just through basic mathematical principles. And so that's why we get that kind of sense of feeling that time's just escaping us. And we can actually see that if we were to plot this for ages 1 through 100, right? In our first years of life, a single day has a very big proportion in your mind. You feel that day, you know that day because you haven't lived very many days, right? And so those first few years, in your early youth, as you're 1 years old, 10 years old, all the way up to 21 is when you start to see really this curve start to flatten out, right? And so this is why in our youth we seem to have this sense that each day is just lasting so long. And that's because it really is, in the perspective of our overall life, we haven't lived enough days for it to feel like it's going by quickly, right? And so the more days we live, the quicker each day feels. And so that's what this is kind of showing us here, showing it to us from a mathematical perspective as to why we have this underlying feeling about time. So the next thing we're going to look into is Adrian Benjay's clock versus mind time misalignment chart. And I apologize if I'm not pronouncing your name correctly, but this man is a physicist and mechanical engineer who has spent a great deal of his time researching and investigating why our perception of time is truly changing and what can be done to stop that progression. So please feel free to research him on the internet. I'm sure you'll get much more in-depth analysis than what I'm going to give here about it. But I think that this chart really goes well with what we're discussing today. So over here on the left-hand side of this chart, we have youth, and on the right-hand side, we have old age, and we have 3 different spectrums that are occurring at the same exact time from youth to our old age. Okay, so let's talk about the first spectrum, where we're dealing with perceived changes in images. So what Adrian Benjay's arguing is that in our early youth, we have perceived images at a much more rapid rate than we do when we are in our older age, right? And this kind of makes sense if we think about it, because we're having a lot more new experiences as we are growing up and developing. We are seeing we're seeing new things and trying to process that and make new memories of it. And what Adrian Benjay calls this is a lot of stimuli. So we have a lot of stimuli in the first part of our life that creates and encodes a lot of these memories. And in old age, right, we don't have those many changes in imagery as much in our vision that we do in our youth. And so the next spectrum that you see is going to be clock time. So this is just how time is actually moving, regardless of how we feel it's moving. And so that's very stationary, and we can see that each unit of time is equally spaced out throughout the course of our life because clock time isn't changing. Okay, and now let's look at the third spectrum he's got on here, which is the perceived duration of one time unit. Okay, so in our youth, the perceived duration of one time unit is much larger than it is in our later parts of life, right? We just actually talked about that from a mathematical perspective, right? We talked about in your early life, time seems to tick on because you haven't experienced very many days. And so that proportion of a day is much longer than it is in your later parts of life, right? And so that's what he's kind of talking about here, is that when you are in your older age, your perceived duration of one single time unit is much closer together, right? They're much shorter than they were in your youth, where they were much further apart in spacing, okay, and in time. And so he kind of makes this argument that if we were to get more stimuli within our later years of life in the same way that we did in our youth, this might be one way to feel like time is stretching out, right? So if maybe we can have these perceived images, if we can increase the amount of stimuli that we get in these older ages, maybe we can feel different, because this duration at the bottom, right, this spectrum isn't going to change. And the spectrum up here also isn't going to change. The only thing we have the right and ability to change in our lifetime is the amount of perceived images that we are getting into our mind every single day. So along those same lines, we have Claudia Hammond's holiday paradox. Claudia Hammond was a psychologist, I believe, and she said that human brains only encode new experiences into memories, right? So in our early years, in our youth, we have tons of new experiences. We're learning new things. We're having all of the traditional experiences that you would expect to have over the course of your life. And each one of those experiences, because it's new, it's fresh, it's not ever something you've done or seen or heard before, it becomes a memory, something that you're going to store to maybe use at a later time, right? And so she also says that with this holiday paradox, humans evaluate time by the number of new memories that are created over a given period of time, right? So if we think about this, we then therefore perceive our earlier lives as lasting longer because we have so many more new experiences during that time of our lives than we do in our older age, where we're just getting up, going to work, doing the same job over and over again, right? So Claudia Hammond also is making the same exact type of argument. We have a lot of stimulation in our lives in the beginning portion. We make a lot of new memories, right? We have a lot of imagery in this time. We know that as we age, that process of developing new experiences slows down, right? We just stop doing it as much. There's not as many new things that we need to learn or that we go out and learn. And so that's happening. And then at the same time that these things are happening, the way that we're judging time is also changing, right? So Claudia Hammond says that we're judging time based upon how many new memories we have. So if we are judging time by how many new memories we're creating, and we're not creating memories in our old age, new memories, then it's going to feel like that time has gone by really, really fast because I can't remember what happened over the last 6 months because I didn't have any new experiences that became new memories. Right. And Adrian Binjay is saying the exact same thing. He's saying that you have all of these images that are coming into your mind as a young child. And as you get older, you stop having those many images, right? And so, because you stop having those many images, and because your perception of a unit of time of day has also changed, right, you're exacerbating the fact. But they're also making another very good argument in this, an argument that maybe we can get out of it, an argument that says, what if we increase the amount of stimuli, the amount of images that are coming into our brains in our old age? Is there a way that we can slow down this time perception? So, in conclusion, we have learned today that days represent a smaller proportion of our overall lives as we age. It gets smaller and smaller every single day. We learned from Adrian Binjay and Claudia Hammond that days become longer when we have more experiences and stimuli. And these are all of my works cited. Please feel free to go and do your own research on some of these. They're all really interesting. And thank you all so much for watching.